And 8.1a is direct and indirect variation. Direct and indirect variation. I'm going to tell you as we're doing it which one we are using. On the worksheet, it will tell you for like the first 1 through 5 odd are direct variation. Then there's a couple 6, 7, and 9 are, I wrote inverse variation. Also no, sorry, it's inverse, not indirect. Inverse variation. Direct variation, inverse variation. So the second chunk, 6, 7, 9 are inverse, but then the rest of them, so it would be 11 through 25 odd and number 22, you have to choose, like, should this be direct or should this be inverse variation? And I'm going to show you how to determine which is which, but just know that on the homework, some of them, it should be like, yep, I know I'm doing direct, or is it direct or inverse on this one? You do have to do some choosing. Okay, so let's start with direct. Direct variation. Direct variation is when two quantities change in the same direction. When two quantities change in the same direction. Basically what we're saying is if your first quantity goes up, then your second quantity will also be going up for direct variation. Whereas if my first quantity is going down, then my second quantity will also be going down for direct variation. Here's a couple of examples. Maybe write one of these down just to give yourself a for instance, but I just want to give you a few. If you are going on a trip, okay, the distance you traveled with the time spent are a direct variation. The longer the distance, the more the time, right? They're both going up. Further the distance, greater the time. So that'd be one example. If you're buying something at the grocery store, like you're gonna buy bananas, okay? The more pounds you buy, the more the more money you spend, okay? So they're both going up. If they went down, if you buy less pounds of bananas, you will spend less money. So both on their way down then, okay? If you're baking and you decide, I'm gonna double the recipe. If I do more sugar, I need to do more butter. They're both going up, okay? So if they're going in the same direction, we always say, hopefully, a direct variation is the time spent studying and the grade on your test, right? You study more, you get a better grade, hopefully. So with direct variation, the equation for that is this. Hold on, my app is not working. Okay. The equation for direct variation looks like this. And this K, it's called your constant of variation. Right now, it looks like it is a variable, but it actually will represent a number that does not change in the problem, okay? So it's your constant of variation. With that, we want to often find out what our constant is so that we can get our equation. So the way we would solve for K right now, what would you do to solve for K? Divide by x. So if I have y equals kx and I just divide by x on both sides, that x goes away and I get that my constant is always equal to y divided by x. So you're going to use this, or you can start with that and move to that second one. But you're going to use that a lot with direct variation. It's always going to get you a ratio, something over something, and you're going to be setting up proportions a lot to solve these problems. Okay, so think proportions when you think direct variation. That will be helpful. Okay, maybe just make a note of that for yourself. if you think proportions with direct variation, that is helpful. Okay. So let me give you an example of what direct variation will look like here. Example 1. Let's say we say this. If 4 bottles of milk cost $4, okay, how many can we buy for $8? Okay, now a lot of you can just do that in your head, but I'm going to use that simple setup to show you how you can actually set this up. Okay, so if we're setting up proportions here, we can tell this is direct variation because the number of bottles is going up and the number of cost would have to go up too then, right? So that's direct variation. So we're going to set up a proportion. We're going to say 4 bottles for $4 should equal how many bottles for $8? Okay, now I feel like these are a lot easier to do if you don't label them, but be careful if you're not going to label them that you don't mix up where things go. Your bottles have to go across from bottles and your dollars have to go across from dollars. If you flip that, you're going to get very strange answers, okay? Oh, I wrote that wrong. 4 bottles of milk were going to be $2, but I made it $4. But we're going to leave it. We're going to leave it. Otherwise, I'm going to mess up your notes. Okay, so if this is the case, very simple. What is x? It's 8. But how do you solve it if you don't see it very simply? You cross multiply. So we would say 32 equals 4x, right? So just say 4 over 4 equals x over 8. Cross multiply, divide by 4. So we would get, how many can we buy? We can buy 8 bottles for $8. Okay, that's how direct variation is going to work. How about this one? A 10-minute phone call costs $1.20. So how much is it going to cost for a 23-minute call? Okay, so number of minutes increases cost, right? So minutes go up, cost goes up. So that's direct variation. So what you're going to say, and it doesn't matter, when you guys set up your proportion, it doesn't matter if minutes are on top or if the cost is on top. What matters is minutes correspond to minutes and cost corresponds to cost, okay? So if I say 10-minute call, and I put that over the cost of $1.20, okay, then over here, a 23-minute call is going to go where? On the top, across from the 10 minutes, right, is some cost. So you set it up and now you cross multiply. 10x equals 23 times $1.20. What? 27.6. Okay, and then we would divide by 10. So x is 2.76, but what are we talking about? Cost, right? So dollars here. So $2.76. Okay, direct variation. Any questions on that? Okay, so inverse variation then. Okay, for inverse variation, maybe you can think through how this is going to go just based on what direct variation was. This is opposite. This is when two quantities change in opposite directions. Okay, two quantities change in opposite directions. So if the first quantity is going up, then the second quantity is going down, right? If the first quantity is going down, then our second quantity is going to be going up. Okay, so they'll go opposite directions. And here's just a couple quick examples of when this could happen. First of all, if you think the number of people on a job site compared to how long the job is going to take, right? The more people we do, like the more people that are working on a job, the less time that job should take. Now, maybe your group projects don't always work out that way, right? But that's what it should be. Or the speed of your car on the way to school and the amount of time it takes you to get to school. The faster you drive, the less time it's going to take you, right? So one going up while the other's going down, or vice versa. Okay, that's inverse variation. It's like a new dance move. Like what is that? Not copyright. I'm going to patent that. Dance move. Okay, so inverse variation looks like this. The equation will be y equals k divided by x. If I were to solve for k here, my constant, what would I do? Multiply by x on both sides. So I know that my constant will always equal x times y. Okay, so this is the inverse equation. This is what our constant will be when dealing with inverses. So before we said we're going to use a lot of proportions for direct variation. For inverse variation, you just do a lot of multiplying of things. You take your two values and you multiply them together and set them equal to the other two values multiplied together. So for instance, I would do something like my x1 value times my x2 value, and it will equal my y1 value times my y2 value. So the things that are related multiplied to the other two that are related multiplied. Okay, and I'll show you what I mean by that right now. So let's say we hired 3 people to paint a house, and they said it'll take 2 days. Okay, one guy calls in sick. I want to know how many days should it take. Okay, well, think about this. This is inverse variation, right? We want products. So if we hired 3 people and it was going to take 2 days, so 3 people times 2 days, but in reality, one guy called in sick, so how many people? 2 people should take how many days? Okay, so call it X, call it D, whatever you want to call it. That means that 6 equals 2x, so you're going to divide by 2, and x would be 3. So we would say how many days? It should take 3 days based on the information that we had. Okay? Oh, we're golden. Example 4. Let's say we have 50 kids going to camp. And if that's the case, then we have enough milk for 10 days. Okay, but then we find out 15 kids don't drink milk, which is just a crying shame. I used to drink milk all the time. I can't anymore. It makes me so sad. I want to know how many days will the milk last? Okay, so think about this. More kids drinking milk means less days that it's available. Makes sense, right? So this is inverse variation. But you have to be a little bit careful with this one. So inverse means we're doing products. We're multiplying. So we're going to do 50 times what? 50 times 10. And we're going to set that equal to, and here's where you have to be careful. 15 kids don't drink milk. 35, right? So now the number of kids drinking milk is 35, not 15. So pay attention to that. So 35 times however many days, we'll call it D for now. So you work that out, you get 500 equals 35D, and we divide by 35. So our number of days is about 14.3. So we would have about 14 1/3 days if 15 of the kids didn't drink milk. Okay? Okay, quick recap. For inverse variation, you are going to do products. A1 times B1 equals A2 times B2, okay? For direct variation, you're going to set up proportions. A1 over B1 will equal A2 over B2. Okay, so just ask yourself the question when you see one of those problems where you have to choose which one is it. Ask yourself the question, if this one goes up, do I think the other one's going to go up too? If they're both going up or if they're both going down, that's direct variation, that's proportions. If one's going up and one's going down, then you're doing products for inverse variation. Okay, questions on that?